Over 4.6 billion years ago, before our sun even existed, the region of space that would become our solar system was just a vast, cold cloud of gas and dust, known as a solar nebula. This cloud floated silently in space until something dramatic happened. A nearby supernova explosion rocked the nebula, causing it to collapse under its own gravity. This collapse triggered a powerful transformation, marking the beginning of our solar system. As the cloud collapsed, it began to spin, forming a flat, rotating disk known as a protoplanetary disk. Most of the material was pulled toward the center, where it eventually ignited into our sun, lighting up the new solar system. The leftover dust and gas in the spinning disk didn't go to waste. Instead, it began to clump together through collisions, forming small rocky bodies called planetesimals. Over time, these planetesimals stuck together, growing into protoplanets, the building blocks of planets like Earth. Our early Earth formed through this chaotic process of accretion, constantly being bombarded by other space rocks. These high-speed collisions heated Earth's surface, turning it into a molten, fiery world. Volcanic eruptions filled the sky with gas, while asteroid impacts shaped the young planet's surface. Earth was violent, unstable, and incredibly hot. But these destructive events were also necessary, delivering key elements such as carbon, nitrogen, and possibly even water, the ingredients for life. Then, one of the most significant events in Earth's history took place. A Mars-sized object named Theia slammed into the young Earth. Over time, the debris from this collision came together and formed our moon. This wasn't just a spectacular event. It changed Earth's destiny. The moon helped stabilize Earth's rotation and tilt, which in turn created more consistent seasons in a more stable climate. As the Earth began to cool, its surface solidified, forming the planet's first crust. Volcanoes continued to erupt, releasing steam, carbon dioxide, and other gases into the atmosphere. Eventually, the steam condensed and began to fall as rain, and it rained for thousands, possibly millions of years. This endless rainfall filled the basins of Earth, creating the first oceans, which would become the cradle of life. In these dark, ancient oceans, life is believed to have begun. Tiny microbes, perhaps the first living things on the planet, began to thrive in this extreme environment. These early life forms didn't need sunlight. Instead, they used the chemicals around them for energy, a process called chemosynthesis. Over millions of years, life slowly evolved and spread. One group of microorganisms, known as cyanobacteria, began performing photosynthesis, using sunlight to produce energy and releasing oxygen as a byproduct. At first, the oxygen was absorbed by the oceans and rocks, but eventually it started accumulating in the atmosphere. This was the beginning of the Great Oxygenation Event, a turning point that allowed more complex life to emerge. While life was evolving, Earth's surface was undergoing constant change. Deep beneath the surface, plate tectonics began to shift the crust, forming continents, mountains, and ocean basins. Volcanoes erupted, continents collided, and entire land masses drifted across the globe. These processes not only shaped Earth's geography, but also played a critical role in recycling nutrients in maintaining Earth's climate over billions of years. The moon, orbiting silently above, continued to influence Earth. Its gravitational pull caused tides, which may have helped early organisms adapt to life between land and sea. These gentle rhythms of water moving in and out could have played a part in life's transition from the oceans to the land. From those tiny microbes to towering trees and intelligent humans, life continued to diversify and adapt to Earth's ever-changing environment. And through it all, our planet evolved from a violent, molten sphere to a vibrant, life-sustaining world. Today, we walk on continents that were once lava, breathe air that was once toxic, and look up at a moon born from a planetary collision. Every element in our bodies, from the calcium in our bones to the iron in our blood, was forged in ancient stars and brought together through cosmic forces. Earth's origin story is not just about geology and chemistry. It's a tale of transformation, survival, and connection. A reminder that we are, quite literally, made of stardust and part of a universe that's been in motion for billions of years.